Namaste. So, in the last few videos, we were looking at the general understanding of how AI is conceptualized in terms of a search problem, the knowledge, various types of knowledge associated, and so on. Okay, and along the way, there was a realization given that knowledge is playing such a crucial role that could be leveraged to build interesting applications. Okay, so this was the birth of the field of expert systems. I had the opportunity to work on this for a fair number of time, and we also built the first expert system shell, which was built in India, and it was available to users at a nominal cost and all that. So you might wonder, what is this expert system shell? So I'll come to it in a minute. So the idea was that to give enough emphasis on the knowledge as the driving factor, and so ask the question. So if you look at a doctor, or you look at a good mechanic, or look at a good investment advisor, it is not the complex reasoning structure that is actually driving their performance. It is the significant amount of domain knowledge that they have, and this knowledge actually comes in two types predominantly, or maybe even three types. One is the conceptual knowledge, right? So, what are the different types of investment? How do they? What are their properties in the longer term, and those kind of things. And what do people look for investment? So, there is a general understanding of these concepts. The second is actual domain knowledge, that this type of investment gives you this much of return over this period, and therefore you can. People with a certain interest might actually be interested in that. Or if you take medicine, the conceptual knowledge is about how human body functions, what are the different organs of the body, how do they interact, and those kind of things. And the domain knowledge is what diseases are caused by something. So if it is, let's say, an intestinal infection, what typically happens there, what kind of symptoms are usually observed there, and what can you do to contain them. So this is the domain knowledge. And in this domain knowledge also, there are, you can further create one more class, which is what defines their expertise. This is because the textbook knowledge that you typically get in any course or in a subject is something that pretty much everybody gets the same kind of knowledge, right? So what a particular bacteria, how does it behave, what kind of infections it causes, what can you do to cure it or to control it. These are all textbook information that you can get. But some doctors, are particularly good at getting to the diagnosis quickly and usually more accurately. And therefore, you wonder, okay, what makes them a better doctor than other doctors? And there are some mechanics, you take the car there, by the time you park, you'll say, oh no, I think this is the problem that you have on your vehicle. So, what is the cause of this performance difference? And that is primarily coming because of the experience that comes in. So, for example, what are the common types of problems, and what do these sounds or symptoms actually look like or feel like? What kind of things are more common in certain areas? So, this is the experience that also adds to the knowledge. So, these three types of knowledge that we can say are defining the kind of expertise or the performance that we attribute to them. So, if you could actually pick up these knowledge types, the different types of knowledge that we talked about, and structure them into a computer program, and then you write an engine or inference engine which can actually interpret these knowledge pieces, then you would have an expert, right? So For example, as what I will call a general rule like this: if temperature is greater than 100 and the duration is more than 3 days and something, then suspect viral fever. So this is possibly the kind of things that doctor actually looks at when you go there and say very high temperature for over a couple of days. Then that's possibly say, okay, this may be viral fever. Then if he also has competing other hypothesis, he might ask you to get a malaria test or dengue test or whatever, and to further narrow down and clarify. So you can think of a doctor's expertise being in some sense captured through this sort of rules. Okay, so you can create a rule based system, and in general the rule would right. So if condition 1 and condition 2 and condition 3 then conclude that attribute equal to 1. You can add more details to it. Typically, the condition can be a simple boolean like has fever, okay, very propositional logic we would want to say, or you can have a slightly richer conditions like age greater than 30, okay, and or you can have more complicated things like if no prior occurrence of fever, okay, so which is more moving into predicate logic. But so these are the core structure of the rule remains what is captured here, right? If condition 1 and condition 2 and condition 3 then conclude attribute equal to 1. Okay, so you can actually use this simple rule structure to actually write down the rules that may define the expertise in some subject. Okay, so I could write my expertise like this. The advantage is that you even any domain, any non-computer person or non-technical person can understand what is written here. So he doesn't have to understand all the programming language and how a computer works or whatever. He looks at them, yeah, that makes sense. But maybe you could also check this parameter, or you could say that viral fever with or some other fever could also be a possibility. So a human expert can actually these rules and understand them without having a computer person sit and explain to you. You can explain this rule to somebody, and when a patient says, "Why did you tell me that I have viral fever?" I can show him this rule and see, I have this rule, and all the conditions of this rule are satisfied. That's why I thought you have viral fever, right? So a very simple mechanism, but it allows me to provide an explanation to the users. It provides a mechanism for me to show the expertise that has been derived from the human expert and make it visible to the human expert. And this is to great strength. Further, what happens is if these all rules in different domains are written in a similar form, I can think of a generic engine. I can have an inference engine which just reads these. But remember, in all of these cases, the temperature, 100, GT, suspect, these are all just strings, right? The system doesn't have to understand that temperature means something that relates to heat or duration is a time span, nothing. You can ask the user what is the temperature and how long is their duration is about the duration of the fever. So he said, I can actually write a generic engine which can read these rules, store them in my memory in some suitable form. You can have a database, you can have it in memory, or you can organize it into a tree structure or whatever. Okay, so you store it internally. And when a patient comes in, I will look through these rules and look at what rules are applicable to him by asking him whether those conditions are true, what are the values of these different attributes, and tell him, okay, this is what I think is your disease. Okay, so this is a very powerful notion, and that is this kind of an engine is called a expert system shell. That is an expert system which is a functioning. So capturing these rules in a the format is generic, but the actual rules will differ from domain to domain. And creating a generic engine which can read this builds a mechanism for me to build different expert systems using the same engine. So I will assign somebody who will go and talk to some particular expert, gather that knowledge, and load it into a rule base like this. So this set of rules is usually called a rule base. And there may be some general properties also, like duration, where is it in days or is it in something. So these details also can be captured in as a property of that attribute. And so once this rule base is done, you can the expert himself can go through various trials by looking simulating various patients, giving the corresponding inputs and checking whether the output is correct, and asking the system what rule was used, why, how it was used, and all that, and you can actually refine the system with the time. Okay, so this was a very powerful model, and a number of practical expert systems were built using this idea. Okay, and so we'll talk more about it. There are some challenges which we'll come back to in a subsequent video. Take care.